Hello guys, welcome back to the course. In this video, we are going to do road modeling and optimizations using Dijkstra algorithm. This project is not going to be the same like previous project because in the previous project, the optimization was done automatically, but in this project, we are going to create the logics from scratch so you will be able to understand the whole process. Okay, so now let's get started. The first thing that you need to do is to install Volume. Let's copy this and let's compile the code. As you guys can see, we have successfully installed Volume. Next, we are going to import several Python libraries. Firstly, we are going to import HepQ. We are going to use this library for priority queue implementations. Next, we are going to import Volume. And lastly, we are going to import heatmap from Volume. Okay, now let's compile the code. Next, I'm going to pick 5 random locations in New York City. So the first locations is Berkeley Center, the second locations is New York University, the third locations is Empire State Building, the fourth locations is New York Hall of Science, and the fifth locations is Queens College, City University of New York. So we are going to assume that there is one bus stop for each locations. In this case, we are going to create bus road. The road needs to pass every single bus stop. The road needs to be the shortest path possible, and it needs to be fully optimized because we want to reduce the travel time for all passengers. Okay, so next we are going to get the geographic coordinate for each locations. As you guys can see here, we have the geographic coordinate for Berkeley Centers, NYU, Empire State Building, New York Hall of Science, and Queens College. You can go to Google and just type in NYU coordinates and you'll be able to find the latitude and longitude. But in this case, I'm just gonna copy and paste these data, and let's go back to Google Colab and let's compile the code. Next, we are going to define simple graph with nodes and edges. Let's create a new variable. I'm going to name it graph. You can name it whatever you want. It is totally up to you. And we are going to store distance between pairs of locations in this graph. For example, the distance between Berkeley Centers and New York University, or the distance between Berkeley Centers and Empire State Building. Okay, so let's get started with the first locations, Berkeley Center. The distance between Berkeley Centers and New York University is 3.5 miles. So let's put 3.5 inside the parentheses, and this is actually supposed to be NYU, not NYC, so let's fix that. Next, the distance between Berkeley Centers and Empire State Building is 5.2 miles. So let's put 5.2 inside the parentheses. Next, the distance between Berkeley Centers and New York Hall of Science is 8.1 miles. So let's put 8.1 inside the parentheses. And lastly, the distance between Berkeley Center and Queens College is 9.7 miles. So let's put 9.7 inside the parentheses. Okay, next we are going to do the same exact thing to the second locations. So the second location is New York University. Okay, so the distance between New York University and Berkeley Center is 3.5 miles. So let's copy and paste this and put it inside the parentheses. Next, the distance between New York University and Empire State Building is 1.1 miles. So let's copy and paste this and put it inside the parentheses, and let's put 1.1 inside the parentheses. Next, the distance between New York University and New York Hall of Science is 7.4 miles. So let's copy and paste this, and we are going to put 7.4 inside the parentheses. And lastly, the distance between New York University and Queens College is 8.3 miles. Okay, next we are going to do the same thing for the third locations. So the third locations is Empire State Building. So let's copy and paste this. The distance between Empire State Building and Berkeley Center is 5.2. So let's copy and paste this, put it inside the parentheses, and the distance is 5.2. Next, the distance between Empire State Building and NYU is 1.1. So let's put 1.1 inside the parentheses. Next, the distance between Empire State Building and New York Hall of Science is 6.5. So let's copy and paste this. And we are also going to put 6.5 inside the parentheses. And lastly, the distance between Empire State Building and Queens College is 7.2. So let's copy and paste this, put it inside the parentheses, and we are also going to put 7.2. Okay, now we are going to do the same thing for the fourth locations. So the fourth locations is New York Hall of Science. So let's copy and paste this. The distance between New York Hall of Science and Berkeley Center is 8.1. Next, the distance between New York Hall of Science and New York University is 7.4. Next, the distance between New York Hall of Science and Empire State Building is 6.5. Let's copy and paste this, put it inside the parentheses, and the distance is 6.5. And lastly, the distance between New York Hall of Science and Queens College is 2.7. Let's do the same thing to the fifth location. So the fifth location is Queen College. Let's copy and paste this. The distance between Queens College and Berkeley Center is 9.7. So let's copy and paste this, put it inside the parentheses, and the distance is 9.7. Next, the distance between Queens College and New York University is 8.3. Next, the distance between Queens College and Empire State Building is 7.2. Let's copy and paste this. And lastly, the distance between Queens College and New York Hall of Science is 2.7. Okay guys, we are done with this graph. Let's compile the code. Let's add another block of code. Next, we are going to create functions to find the shortest path that visits all specified nodes exactly once, because we want to make sure that the bus route passes every single bus stop. Okay, so let's create the functions. I'm going to name the functions find shortest path. You can name it whatever you want, it is totally up to you, and this function has two parameters. The first one is graph and the second one is nodes. Inside these functions, we are going to import iter tools for generating permutations. Import iter tools. Next, we are going to generate all permutations of the nodes. Let's create a new variable. I'm going to name it all path. And we are going to utilize the iter tools. Let's copy and paste that. Dot permutations. And let's copy and paste the nodes, put it inside the parentheses. Next, we are going to initialize the shortest path. Let's create a new variable. I'm going to name it shortest path. And for now, it is going to be an empty variable. So we are going to set this to none. Next, we are going to initialize the minimum distance as infinity. So let's create another variable. I'm going to name it min distance. Next, we are going to create for loop to iterate through all permutations and find the shortest path. For path in all paths. So let's copy and paste this. Inside this for loop, we are going to initialize the total distance for the current path. So let's create another variable. I'm going to name it total distance. And I'm going to set this to 0. Next, we are going to create another variable. I'm going to name it valid path. In this case, we are going to assume that the current path is valid, so we are going to set this variable to be true. So this is going to be a Boolean variable. Next, we are going to check if the path is valid. So it means that it can travel between consecutive nodes. Let's create another for loop for I in range. The length of the path subtracted by 1. Inside this for loop, we are going to set the current node in the path. Let's create a new variable. I'm going to name it current node. Let's copy and paste path. And we are going to put I inside this bracket. Next, we are going to set the next node in the path. Let's create another variable. I'm going to name it next node. Inside this bracket, we are going to have I plus 1. Next, we are going to assume there is no edge between current node and next node. Let's create a new variable. I'm going to name it font edge. You can name it whatever you want, guys. It is totally up to you, and this is going to be a Boolean variable. Let's set this to false. Next, we are going to create for loop to iterate through neighbor of current node. For neighbor, comma wait in graph. Let's copy and paste this. And we are going to put the current node inside this bracket. Inside this for loop, we are going to create conditional statement to check if next node is a neighbor. If neighbor is equals to next node, let's copy and paste this. So if this condition is met, then we are going to add the edge weight to the total distance. So we are going to reuse this variable. Let's copy and paste that. And we are going to do increment. Let's copy and paste weight and put it here. Next, we are going to set the font edge to true. Let's copy and paste this variable. Okay, next, we are going to exit the loop since the edge is found. Break. Next, we are going to create another conditional statement to check if no edge is found. If not found edge, then we are going to set the valid path to false. So let's copy and paste this. And we are going to replace true with false. And we are going to exit the loop. Next, we are going to create another conditional statement to check if the path completes by reaching the last node. If valid path and path, we are going to put 0 inside this bracket because we want to access the first element in this list, equals to, so the first locations is Berkeley Center, right? So just copy and paste that. And path -1. So this is supposed to be like the lost locations, which is Queens College. So let's copy and paste this and put it here. And total distance is less than minimum distance. So let's copy and paste the total distance and let's copy and paste the minimum distance. Let's copy and paste this. Okay, so if these conditions are met, then we are going to update the minimum distance. So now the minimum distance is going to be the total distance we are also going to update the shortest path. So if these conditions are met, then the shortest path is going to be path. These functions is going to return the shortest path and its distance. Let's copy and paste the shortest path and also the minimum distance. Okay guys, we are done with these functions. Let's compile the code. Let's add another block of code. Next, we are going to define the nodes to visit in the specified order. So let's create a new list. I'm going to name the list nodes to visit. You can name it whatever you want, guys. It is totally up to you. Okay, so the first locations is Berkeley Center. So let's copy and paste this and put it inside the bracket. The second locations is New York University. So let's copy and paste this and let's put it inside the bracket. The third locations is Empire State Building. So let's copy and paste this and put it inside the bracket. The fourth locations is New York Hall of Science. So let's copy and paste this and put it inside the bracket. And the fifth locations is Queens College. So let's copy and paste this and put it inside the bracket. Okay, next we are going to find the shortest path that visits all nodes exactly once, because we want to make sure that the road visits every single bus stop. Let's create two variables. The name of the variables are going to be the same like what we used in these functions. So the first one is shortest path, and the second one is total distance. Okay, now we are going to utilize these functions, find shortest path. And remember guys, these functions has two parameters. The first one is graph and the second one is nodes. Okay, so in this case, we are going to use this graph. Let's copy and paste this and put it inside the parentheses. And the nodes is going to be this list, nodes to visit. So let's copy and paste this and put it inside these parentheses. Next, we are going to print the shortest path and total distance. Let's copy and paste this variable shortest path. And we are also going to print the total distance, right? Let's copy and paste this variable and put it inside the parentheses. Next, we are going to define coordinates for each node. Okay, let's create a new variable. I'm going to name it coordinates. You can name it whatever you want. It is totally up to you guys. So the first locations is Berkeley's center. So let's copy and paste this. And we are going to set this to Berkeley's center coordinates. The second locations is New York University. Let's copy and paste this. And we are going to set this to New York University coordinates. The third locations is Empire State Building. And we are going to set this to Empire State Building coordinates. The fourth locations is New York Hall of Science. Let's copy and paste this. And we are going to set this to New York Hall of Science coordinates. And the last locations is Queen College. Let's copy and paste this. And we are going to set this to Queen College coordinates. Next, we are going to create the map using volume. The map is going to be centered around Berkeley's center. So let's create a new variable. I'm going to name it map center. Let's copy and paste the coordinates. And we are going to put Berkeley Center inside this bracket. Let's create a new variable. I'm going to name it my map. You can name it whatever you want. Volume.map. Okay, so now we are going to specify the locations. So we are going to set the location to map center. Let's copy and paste that and put it inside the parentheses. Next, we are going to set the zoom start to 12. Next, we are going to add markers for each nodes. So you will be able to see each locations in the map. So let's create for loop, for node, comma coord, and coordinates. So let's copy and paste this, and we are going to add dot items. Inside this for loop, we are going to add the marker, volume dot marker, and we are going to put coord inside the parentheses. We are going to set the pop-up to node. So let's copy and paste this and put it inside the parentheses. And don't forget, we will need to add this to the map. Add to copy and paste the my map and put it inside the parentheses. Next, we are going to add the shortest path as a polyline. So let's create a new variable. I'm going to name it path coordinates. Let's copy and paste the coordinate and put it inside the bracket. And we are going to put the node inside this bracket. For node in shortest path, next we are going to create the polyline. So volume dot polyline. We are going to specify the locations. Okay, we are going to set the locations to path coordinates. Let's copy and paste this, put it inside the parentheses. Next, I'm going to set the color to blue, but if you want to use different color, it is totally up to you guys. I'm going to set the weight to 5, and I'm going to set the opacity to 0.7. And lastly, don't forget to add the polyline to the map. Add to. Let's copy and paste the my map and put it inside the parentheses. Next, we are going to save the map as an HTML file. So my map.save. In this case, I'm going to name it shortest path.html. You can name it whatever you want. It is totally up to you. And lastly, we are going to display the map. Before compiling the code, there are two mistakes that we need to fix. The first one is the polyline, so this is supposed to be uppercase. And the second mistake is 8,1, it is supposed to be 8.1. Okay, so let's recompile this code. I really apologize for this mistake, guys. Okay, so now we are going to compile this code. Okay, so here is the output. So the total distance is 13.8, and here is the map. Locations 1, 2, 3, 4, and 5. So this is Berkeley Center, this is New York University, this is Empire State Building, this is New York Hall of Science, and this is the destinations, which is Queens College. Alright guys, I think that's it. That's all you need to know. I'll see you guys in the next video. Bye.